Hi, welcome back. In this lecture, I would like to give you an example of MPI one-sided communication. The example I want to provide includes two or more processes where the process is having some local values. So for instance, P0 here is going to have 0, 1, 2, 3. And then P1 is going to have other four number. And what I want to do is actually to each process to expose an area as an MPI window, where then we do the following operation. So we take the local values from one processes, and then we put on the window an MPI window of the process that is next to it. So we are going to do using basically two major operations. I'm going to use a simple active target synchronization using MPI win fence. And then I will write to the MPI window using MPI put. So this is the following. As usual, we start initializing our MPI environment with MPI init thread. I get the what is my rank and what is the size of the communicator, so how many ranks there are. And then what we are going to do is to have we're going to have two arrays. So one is the local memory, and then one is we call the share memory. So these are two arrays, and then we basically attach this array to our MPI windows. After allocating the arrays, we also fill it. So we filled the local array as basically the rank multiplied by n, in this case is 4, plus I. So each process is going to have 4 values. And also we initialize the share memory. We will attach then to MPI window with a 0, right? So share data is going to be 0 before the communication. The next step is actually to create an MPI window. That is, an MPI window is a remote memory that can be directly accessible remotely by other processes. So in this case, we're going to define an MPI window object. We call it win. And then, as you remember, there are two ways to create MPI windows. I use the MPI win create, where I give basically the pointer and basically the size. So here we basically, at this point, we create a window win that we can access from other processes. So each process will have a window. At this point, we want to start an epoch. Remember that MPI side communication can happen only within an epoch. So there are different ways to create an epoch. So we saw the active target, generalized active target, and then also we saw the passive target synchronization. The simplest one is basically MPI fence. So we use MPI win fence at the beginning to start, and then MPI win fence to delete. So we started, and then here we use a put to write our values from the local memory to the remote memory, and we also provide which process, in this case, we want to give to the windows on the next process. And then we basically use MPI win fence to close the window. After, so the major point here, remember that we always need to start an epoch, do the communication, one-sided communication, and then stop the window. So we print our data, and then we need to remember to free our windows. We can simply run this on a supercomputer cc MPI one-sided.c, and then we can run with 2 also more. And what we get is basically MPI rank 0 will get the values from rank 1. So these are the 4, 5, 6, 7, and the MPI process with rank 1 will got the values from the rank 0. So this was the last slides, and talk to you soon.